exercise. Purpose: the regression report must show y hat is a plus bx, including names of dependent and independent variables. Dependent variable is y on the left, independent variable is x on the right. So y hat r square, coefficient of determination s sub e, standard error of estimate of y, and here hat is estimate. Y is the actual y value, y hat is the estimated value given by the regression equation. 2. You must know the locations of these basic answers in Excel output. Problem 1. A researcher develops a regression model. Regression model is the regression equation y hat is a plus bx. To predict the systolic blood pressure. Therefore, systolic blood pressure is the dependent variable y. The variable to predict is y. From h, you will use h in prediction. Therefore, h is the independent variable, or you call the predictor independent variable x. After running regression analysis by Excel, you will get this output. There are 3 parts. You can read each one and look for. Here, multiple R, this is the regression coefficient. R, this is R square, coefficient of determination. Without learn, just that R square. Standard error of estimate S sub E. This is this value. So we study these 3, R square, S sub E. And the next one is called the ANOVA table. After that, the last table, 2 rows. This is called the parameter estimate table or coefficient table. Coefficients, they are intercept, y-intercept. You call y-intercept or the constant. Yeah, A is called the y-intercept or A constant. B is called the regression coefficient, not correlation coefficient. Yeah? Regression coefficient or slope of the regression line. You read the values of A and B in the last 2 row table here. Y-intercept A, this is 72 by this value. H, this is x. Here, independent variable shown by this arrow, right? So B is here, 1.328 something. Yeah. SB is here, SB, S sub B. Yeah, S sub B is S sub E divided by square root of sigma A square minus N X bar square. Okay. You don't learn T statistics P values yet. What is the regression equation? So y hat is A plus bx. Here you write 72.71. If you cut at the second decimal, or if you cut at the fourth decimal, 72.7057 plus 72.7. Here you see, you can see below here. A is 72.71 approximately, B is 1.328 times axis is axis, and y hat. Estimate the blood pressure y. Estimate y hat of the individual who is 45 years old. X is 45, so you enter 45 here and compute by calculator. You will get this. And r square is, you just copy from here, r square 0.8146, 815 if you cut at the second, that decimal. S sub e is standard error of estimate. You have seen this. S sub e is 9.190995, therefore 1910, 9.1910, this one. So all correct. Problem 2. An industrial psychologist would like to develop a model to predict the number of typing errors based upon the amount of alcoholic consumption. A random sample of 8 typists was selected with the following results. 3 exact outputs are given below. So read again. An industrial psychologist would like to develop a model to predict. Therefore, this is an equation to compute number of typing errors y based upon using amount of alcoholic consumption x. For us, this is the linear regression equation. A random sample of 8 typists, number of cases, sample size, and 8 pairs of data. Alcoholic consumption x, number of errors y. The first typist consumed alcoholic consumption 1 ounce, ratio level measurement. Number of errors counting, ratio level measurement. He or she made 2 errors. The second typist consumed 2 ounces of alcohol and she or he made 6 mistakes, and so on. So 1, 2, 3, 4, 5, 6, 7, 8 pairs. Go with the output. This output, in this output, this is a false output. Why? Because here the yellow mark, you can see number of errors. Here in this last table, 2-row table, in this position you must see x, but now you see y. This is y, in the problem, y. So false. So this output A1 shows regression for estimating alcoholic consumption, not to estimate number of errors. Therefore, this is a false output. So you have to remember 2 key points. The dependent variable is typing errors, number of errors. Sample size is n, 8. And in output A2, what is wrong? Number of errors y, number of errors, this is also false, y here false. Also here false, n is 8, not 5. How about the first one? Here in the first output, number of observations is 8. This is correct, Okay, outputs A1 and A2 are false outputs. Here explain also. This is a regression model for predicting amount of alcohol from number of errors. Actually, we want the model for predicting errors. from amount of alcohol. This is the first mistake. The second mistake is sample size wrong, not 5, 8. Output A3, this is correct. Why? If you see no mistake you find, therefore if you have to choose the correct output from A1, A2, A3, you must not choose A1, A2. We don't see any mistake in A3, therefore A3 we must choose A3. Here X is alcoholic consumption, correct. N is 8, correct. So this is the correct output to use. Using this output you can compute, you can compute here y hat is predict the number of errors made by a typist who has consumed 2.5 ounces of alcohol. X is 2.5, A is 1.494, B is 2.5118. So you compute A plus B times 2.5 equal to, then you write regression equation here. A 1.49 plus B 2.512 and X alcohol. So this is the answer for number 1 question. Number 2, if you enter 2.5 and compute, you get 7.7 errors. X is 2.5. R square you can copy from the table. R square is here, S sub is here. So you copy these two. So you have to read and note the key points, features of the problem, and select the correct output if you are given several outputs together. After that, you know the location of statistics where A, B, R square, S, E, R.